In this video, we're going to be talking about adding and subtracting fractions, specifically with models. So we have three different models for fractions. We have the area model, the line model, the set model. We have three different manipulatives we usually use with this. For area model, we usually use the pattern blocks. For line model, we usually use the Cuisenaire rods. For set models, we use something. It can be like M&Ms, Cheerios, color counters, whatever you need to for that. For this lesson, we're actually going to use some different things other than just those specific manipulatives. And the reason why, for an area model, when you're adding and subtracting fractions, if you're using pattern blocks, there's only so many problems you can do, because if you think about like the pattern blocks that we have, we can only split it into 4s and 3rds and 6ths and 12ths. Like, we can't split it, the pattern block, the hexagon, into 8ths, because I don't have a shape that makes that. So that's why we're just going to use rectangles instead, because with rectangles you can split it into any size you need to. For the line model, same thing. Cuisenaire rods, it only goes up to 10. I could put some together, but it's just kind of a lot of work. So instead we're just going to use a number line for it, and then we're just going to use dots on the set model. Okay, so let's talk about how we add fractions. So if I wanted to add 1/2 plus 1/3. Okay, so if you are talking to a young child adding 1/2 and 1/3, more than likely they could get you kind of headed in the right direction. Say, well, 1/2, 1/3 is a little bit smaller than 1/2, so this isn't going to be a full whole, it's going to be less than a whole. Sadly, once you get up to like older students, like high school, 1/2 plus 1/3, so very often they try to say, well, 1/2 plus 1/3 gives me 2/5, and that's my answer. And it's just because they're just trying to, they're not thinking about the problem. They're not actually thinking about what 1/2 is and what 1/3 is. And I think part of it's just because they're so scared of fractions. So our goal is to get students super comfortable with fractions using different models, pictures, real life examples, so that they don't shy away from an operation like this. And this is obviously not correct, because 1/2 is half of a whole, 1/3 is almost half of a whole. It's not quite, but it's almost half of a whole. So this should be close to a whole when I add these two numbers together. Less than a whole, but close. And 2/5 is a whole lot less than even 1/2, right? All they did here was just add 1 plus 1 is 2, and 2 plus 3 is 5. Okay, so let's start off with an area model here to talk about how to add 1/2 and 1/3. Okay, so usually the way we do this problem is to get a common denominator. When you start off teaching adding fractions, you don't actually use the word common denominator. You are finding a common denominator, but they don't even realize that's what they're doing. So let's use this problem, 1/2 plus 1/3. So let me take a rectangle. So that's my whole for this problem, and let me split it in half. So I'm going to split it in half like that. If I want to show one out of two pieces, split it into two pieces, shade in one of them. So this is 1/2 right here. Okay, if I want to add to that 1/3, then I would draw the same rectangle. This time I'm going to split it into 3 pieces, but I'm also going to split it in a different direction. So this way I split it horizontal. I'm going to split it vertical this way. So to show 1/3, I'm going to shade in one of my pieces. So it's easy to see this is 1/2, this is 1/3. And hint, when you're doing this, cut your pieces in opposite direction. So draw pieces in opposite directions. Okay, so if you asked a student to add this and this, half of a rectangle, half of a circle, and add 1/3 of a circle, they'd say, I can't really do that because I don't really know, like, these pieces aren't the same size, so I can't say I have 2 pieces. I don't know how much makes the whole in that case. So what we can do Instead of trying to add it like that, we can overlay your cuts. So what I mean by that, I'm going to do it with red pen. This one I have split in half this way. Let me go ahead and split this one in half that way also. Okay, so I'm going to redraw it down here so that I don't change that first part of my problem. Okay, so this is still 1/2. I'm still shading it purple on top. So this is still 1/2. This one is still 1/3. Still splitting in 3 pieces, still shading the top part. But now, with a red pen, I'm going to split this one in half this way and split this one in thirds vertically. And the reason why I did that is because now I have equal pieces and I can see easily how to add 1/2 and 1/3. The difference here is the name of this changed. How would I describe the purple pieces? Well, now it is, I have 3 parts shaded. How many parts make a whole? 6 parts make a whole. And for this one, I have 2 parts shaded. 6 parts make a whole. So if I want to add them together, draw your whole, which has 6 pieces now. Shade 3 of them purple. Shade 2 of them yellow. And now it's easy to see how many pieces are shaded. Well, 5 pieces are shaded. How many make a whole? 6 pieces make a whole. So your answer is 5, 6. So we got a common denominator just by overlaying our pieces so that we have equal pieces now and we can add them up. Okay. So let's do another one of those, and let's do it with subtraction this time. Okay, so we'll call that problem number 1. So for problem number 2, let's do 3/4 minus 1/3. So I need to draw 3/4. So draw a rectangle, split it into 4 pieces however you want to. I'm going to split it vertically this time. I like to do my vertical cuts the bigger number and my horizontal cuts the smaller number, but it seriously doesn't matter. It's however you want to do it. So this is 3/4. I'm shading in 3 pieces, 4 make a whole. So that's 3/4. I'm going to take away 1/3. So draw a hole, split it into 3 pieces now. I'm going to do this horizontally because I already did the other one vertically. I didn't do a very good job making it very equal, but you get the idea. 1/3 is 1 piece shaded. 3 make a whole. So I'm taking away 1/3. Right now, it's hard to see. I can't take away a yellow from a purple because they're not the same size. So instead, let me redraw it and let me overlay my pieces so that my cuts match up. So I'm going to draw 3/4 again. I'm going to draw 1/3 again. Try to do a little better job this time. I'm going to shade in 1 piece out of 3. I'm going to shade in 3 pieces out of 4. This time, I'm going to overlay my cuts. So I'm going to split the first one horizontally. I'm going to split the second one vertically, because now they're all equal pieces. So now you can rename your fraction. Instead of 3/4, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces that are shaded in, and there are 12 total pieces. Minus on the other one, there are 1, 2, 3, 4 pieces shaded in out of 12 total pieces. And now I can subtract. If I have 9 pieces and I take away 4, let me cross them off one at a time. 1, 2, 3, 4. So my answer is still my whole rectangle split into 12 equal pieces. I only have 5 pieces left that are shaded in. So my answer is 5 pieces are shaded, 12 make a whole. So 5/12 is my answer. Okay. If you were doing an addition problem, like if I was adding this and it was 9 pieces plus 4 pieces and it makes more than a whole, I would need to draw 2 different rectangles here and shade in all of one of them and then a piece or however many pieces you need in the other. And then your answer could be like 1 and 1/12, or you could write it as like 13/12 or however you want to. Okay, so that's the area model. Let's move on over to the line model now. So for the line model, I'm going to use a number line to do these same 2 problems. So if I add together 1/2 plus 1/3. The line model is a little bit more difficult because you have to think how to describe your fractions or how to name your fractions. Here it's pretty obvious because it's parts and wholes. It's a little bit more difficult to do it here. Okay, so if I want to add 1/2 to 1/3, what I'm going to start off with is I'm going to draw a 1/2 on my number line. So I'm going to draw a number line and split it into halves. So split it into 1/2. Okay, so here's my number line. It's going to start at 0. I'm going to go ahead and put, I know this is smaller than 1, so I know I only need to go up to 1, but you could go up, if you needed to go to 2 or 3, you could go up higher than that. Okay, so let me start off by splitting it in half. Okay, so one line down the middle splits it into 2 pieces, and so I'm going to label my pieces. This first part is 0, the middle is 1/2, that's 1. Okay, so that's my first step, is 1/2. So now, I need to split each piece that I just made into the other denominator. So I need to split each of this piece right here and this piece right here. I need to split each of those into 3 parts. Okay, so this piece right here I'm going to split into 3 parts, right like that. This piece right here I'm going to split into 3 parts. Okay, not too bad so far. The hardest part of this is now labeling your number line. Okay, so now we need to label our pieces, and when you label your pieces, that's 0. This is 1 part. You have to figure out how many parts make a whole here. That's not 1/3, because if this is my whole, I have 1, 2, 3, 4, 5, 6 parts make a whole. My whole is split into 6 pieces. So this is actually 1/6. This piece right here is 2 parts, 6 make a whole, so 2/6. This part right here, I already have it labeled, but I could call it something different. It's 1, 2, 3 parts, 6 make a whole. Okay, so I could also write this as 3/6 if I wanted to. This would be 4/6, this would be 5/6, and a whole could also be called 6/6. Okay, so once you have it labeled, now I need to draw a 1/2 and add a 1/3 to it. So 1/2 would be from 0 to 1/2. And then this is the other little bit of a tricky part. I need to add a 1/3 to that. Well, I don't have a 1/3 written here, so I have to think in terms of my parts. Okay, so 1/3, if I have 1/3 and I want to turn that into 6 pieces, how many pieces are in each 1/3? So if I have 6 pieces here, it would be 2/6 in each 1/3. So 1/3 is equivalent to 2/6. And so I need to add 2 more 6 to it. So 1, 2 more 6. So 1/2 plus 2/6 is 5/6. Okay. Let's do another one of those. let's do a subtraction this time of those. So let's do the same problem we did a minute ago and do the 3/4 minus 1/3 using the number line. So 3/4 minus 1/3. So I need to draw on my number line. I'm going to split it into fourths first. So draw your number line. If I'm doing less than a whole and I'm taking away less than a whole, it's going to be less than a whole. I don't need to go above a whole here. So let me split it into 4 parts. So if I split it into 4 parts, 3. So 3 lines, 3 little tick marks make 1, 2, 3, 4 parts here. So let's name these parts. If I split it into four parts, the first one would be 1 part out of 4 parts make a whole. The second one would be 2 parts out of 4 parts make a whole, or you could write it as 1/2. The third one would be 3 parts out of 4 parts make a whole, and the last one would be 4 out of 4 parts. Okay, so I split it into fourths. Now, each individual piece I need to split into thirds. Okay, and I got the 3 because that's the other denominator. So here, I need to split this into thirds, split this into thirds, this into thirds, this into thirds. Now I need to name my pieces. This piece right here, it is 1 piece out of how many pieces make your whole? How many go up to 1? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces make the whole. So that's 1/12. This is 2/12. That piece that's already named is 3/12, which is the same thing as 1/4. 4/12, 5/12. 6/12 is the same thing as 2/4. It's also the same thing as 1/2. 7/12, 8/12, 9/12 is the same thing as 3/4. 10/12, 11/12, and 1 is the same thing as 12/12. So now, start off with 3/4, take away 1/3. So if I start off with 3/4, I go from 0 to 3/4. So that's 3/4. Now I need to go backwards, take away 1/3. Well, it's kind of hard to see 1/3 from 3/4, so let's think about it in terms of 12ths. Okay, so 1/3 is the same thing out of, if I take my 12ths and split them into 3 parts, there's going to be 4 in each part. So 4/12 is what I'm taking away. I'm basically getting a common denominator here of 12. So I need to take away 4/12, so that'd be 1, 2, 3, 4/12. I'm going backwards. And I end up at 5/12. So 3/4 minus 1/3 equals 5/12. Okay, so that's the line model. Let's go ahead and go over to the set model now. For the set model, I'm using dots to do these problems. Okay, so let me start off with the same problem. 1/2 plus 1/3. Okay, so you're going to draw 2 sets. So if I'm going to draw 2 sets, I'm going to put a circle here for set 1 and a circle here for set 2. So this one's going to be 1/2. This one's going to be 1/3. So I need to show half of a set here, and I need to show a third of a set here. So the way to figure out how many dots need to go in your set, it needs to be able to split into halves and thirds, and so you would just do 2 times 3 to figure out how many dots you need. Okay, so your sets need to be the denominator dimensions, so like 2 rows by 3 columns, or vice versa. It could be 2 columns by 3 rows. Okay, so I'm going to draw 6 dots in there. If I want to show 1/2, I need to shade half of those dots. Okay, so if I'm going to shade half of the dots, I'm going to shade 3 dots here. Because it's 2 groups, shade in one of the groups. Same thing over here. The set should be the same size. It's still 6 dots. I need to shade in 1/3 of them. So I'm going to split them into 3 groups like this. And I need to shade in one of those groups. So this is 1/2, this is 1/3, and the reason why, again, this is 1/2 is because I split my hole into 2 pieces. I shaded one of them. Over here, I split my hole into 3 pieces. I shaded one of them. So now when I add them together, my answer is still the whole circle with 6 dots inside. Let's see how many are going to be shaded. Let's shade in the 3 from the first set. And then let's shade in 2 from the second set. And so my answer is, how many dots are shaded? Well, 5 dots are shaded. How many dots do I have total? 6 make the whole. Okay, so it's kind of similar a little bit to the area model. You just have to think through at the beginning how to divide up your sets. Okay, so let's do the subtraction problem, 3/4 minus 1/3. So 3/4 minus 1/3. So in this case, I'm drawing 2 sets, but each set needs to be 4 rows or 4 columns by 3 rows or 3 columns, however you want to do it. So here's my set for 3/4. Here's my set for 1/3. I'm going to subtract them. So 4, 1, 2, 3, 4, 1, 2, 3, 4. Oh, I did that right. This is 4. It's 4 columns by 3 rows. I did that backwards, but it doesn't matter. Same thing over here, because your set's going to be the same. And your answer is going to be still, this is my whole. I just need to shade in now. So if I need to show 3/4, I'm going to split my set into 4 parts. 2, 3, 4. Shade in 3 of those parts. For this one, I want to split my set into 3 parts. 1, 2, 3. I want to shade in one of those parts. Given 1, 3 make a whole. And then subtracting, I'm taking away. So I'm marking them off one by one until my second set is empty. So my answer is, there are 5 pieces still shaded or left over. So 5 are shaded in. How many make a whole? There are 12 pieces still that make a whole. Okay, so that is the area model, the line model, and the set model for adding and subtracting fractions. In the next video, we'll talk about different methods for adding and subtracting some mixed numbers.